So this is for numbers 6 and 7 on the 2.10 homework. Just once again, kind of that extra push for you guys. It's not just a straightforward question that we talked about in class. Something to make you think a little bit here. So what I want you guys to notice here for number 6 is that they are giving us a second derivative, right? But it's asking for a particular solution. In other words, it wants to know what's the original function. So how do we go from a second derivative to a original function? Well, the answer is you need to integrate twice. Because the first time you integrate, it's going to give you an f prime. And then the second time you integrate, it's finally going to take us to an f again at that point. So basically, guys, that's going to be our plan, is we're just going to integrate twice. And every time you integrate, you get a plus c, right? And we're going to need to find the plus c. So the first time we integrate, we're going to have to plug in this to find the first c, because the first time we integrate, we're going to get an f prime expression. And the second time we integrate, we're going to need this to find the second c, because we'll need to find the c for the f expression. So that's pretty much our plan. So at this moment, I've got f double prime of x is equal to 1/2 of e to the x minus e to the negative x. Now what I'm going to do is I'm going to put a dx next to both of these and integrate both sides. And whenever you integrate the left side, it goes from being f double prime to f single prime. On the right, we're going to do some algebra magic here. I'm going to distribute. And after I distribute, I'm going to be taking the integral of these two things separately. All right. And then the next thing we need to do is actually do the integration at this point. So, sorry about that. Make some space for myself here. Okay. Now, first of all, I'm just going to take the half out, because we don't really need to have that in there. It's a constant multiple. It's easier if you take it out. And I'm going to do the same thing on the second one as well. Okay. Now, the integral of e to the x. Now, if you haven't watched the lesson yet, then you might not know what that is. But if you have watched the lesson, the integral of e to the x is just e to the x. And that makes sense because the derivative of e to the x is e to the x. So if you integrate and go backwards, you get the same thing. Now for the second one, though, we have a little bit of a bump in the road to deal with. It's not e to the x, it's e to the negative x. Now, I'm going to do it the long way, and then after I do it the long way, I'm going to tell you guys the short way, so you never have to do this again if you remember it. But the long way is it's a u sub problem, and whenever you're integrating an exponential function like this, the u is almost always going to be the exponent. And so if I solve both sides for dx, I end up with dx is equal to negative du. I'm going to show my work for the rest of the integral on the side here, just because I don't want to. I'm running out of vertical space. So if I do my actual setup here, then it's going to be e to the u, and then negative du. Now that negative that I have with the du, I'm going to take that out and put it in the front, which is going to make that half become a positive. And then once again, the integral of e to the u is just going to be e to the u. And our u was negative x. So I'm going to put all that in where this was now. So I have f prime of x is equal to 1 over 2 e to the x plus 1 over 2 e to the negative x. And we don't want to forget our plus c. Okay, so that's our first integral. Now, I told you I was going to tell you a little shortcut. Anytime you have an e to the negative x, it's just like this one. Whenever you integrate this, you just get e, right? Well, the only difference is when you integrate e to the negative x, you still just get e to the negative x. It just changes the sign from being a negative to a positive. It just switches the sign. So if you want to memorize that as a little shortcut, you can. And I think that'll actually come in handy when we move in to do the second derivative. But we need to find the c. And after I find the c, I will know what f prime is. And once you know what f prime is, we can integrate one more time to find the f. So let's go ahead and we'll find the c at this point. Since this is f prime, I'm going to use this initial condition right here. I'm going to plug in 0 for x. F prime of 0 equals 0, so I'm just going to replace f prime of 0 with a 0. And all of these things equal 1. So basically, I'm left with 1/2 plus 1/2, which is 1/4. I'm sorry, 2/4, right? No, it's 1. Sorry, little brain problem there. 1/2 plus 1/2 is 1, so that just ends up being 1. And therefore, my c value ends up being -1 if you subtract it on both sides. So now I have the following. I'm going to replace my c with -1. And there's my f prime. But we're not done, right? Because we want to get f, not f prime. So how do I turn f prime into f? We integrate again, right? So I'm going to take my f prime, which we've already said is 1/2 e to the x plus 1/2 e to the negative x minus 1. And we're going to put a dx on both sides. And then we're going to integrate both sides. When I integrate this, I get f. Then we're going to integrate each one of these three things separately. And I'm leaving off the dx just for space right now, but each one of these integrals should technically have a dx on them. I'll put it on this one. But technically there should be a dx on all three of those. It doesn't really matter. So I'm going to take this half out and put it in the front. And when you integrate e to the x, you just get e to the x again. I'm going to take this half out and put it in the front. And when you integrate e to the negative x, I gave you guys a little shortcut on the last page. You still get the same answer, e to the negative x, but it changes the sign. So now it goes back to being -1/2 instead of positive. Now, if you want to go through and do the u substitution thing again, you can, but you'll get the same answer. And then finally, in this last one here, -1. If you integrate a constant, you just put an x next to it, so it ends up becoming just x, and we don't want to forget our plus c. So now I've got my f of x, and we're ready to use that initial condition to find c for the last time. So I'm going to plug in 0 for x. F of 0 is 1, so I'm going to replace that with a 1. E to the 0 is 1. So 1 times 1/2 is just 1/2. Same thing here. We don't care about that 0. We can ignore that. Those cancel out, and I'm left with c equals 1. And so I'm just going to put that now in my final answer for c. And I have my final answer there. Okay, so the trick there basically is just to integrate twice, find your c both times, and that should get you there. And so number 7 is similar to the last one that we did. We're going to just start by taking our expression here and integrating both sides so that we can change it from an f double prime into an f prime. Once again, I'm going to integrate each of those pieces separately. The integral of sine, a little bit tricky, is negative cosine. And now if you guys notice, when I first wrote this, I forgot to include the prime, but there should be a prime right there. Now as for this next one, let's figure it out. I'm going to do my work for this on the side. We're going to have to do some u substitution. And then I'm going to show you a shortcut again, just like I did in the last one. And technically, the shortcut I'm going to show you for this one is the better shortcut because it works for the last one also. But let's see how it works. So we're going to let u equal 2x. We're going to say that the derivative of u with respect to x is 2. Got that. Then we do our u substitution. We have that. I'm going to factor that 2 out to the front. And then the integral of e to the u is just e to the u. Don't forget our plus c. And then we'll put the u back in. So I end up getting 1/2 e to the 2x plus c. Now what's the shortcut though? I'll show you the shortcut, and you'll like this because it happens quite often actually. Not all the time, but it does happen quite often where anytime you have an e to a ax problem like that, anytime you integrate one like that, it comes out to be e to the ax, but 1 over a. That's just how it's always going to end up looking. So it might save you some time in the future. And that would have worked for the last one too. You guys remember how it was like a -1 here? Well, in that case, your a is a -1, so you would just have 1 over -1, which is still just -1. It just changes the sign. So that's kind of the better rule to memorize right there. All right, so anyway, there's our f prime. Now we plug in our initial condition for f prime, which is 0 for the x. Now cosine of 0, we have to know what that is on our unit circle. 0 is at the right, the extreme far right of the unit circle. Cosine is the x value, so the extreme far right x value is 1. And since there's a negative in the front, it's going to be -1. Anything to the 0 power is 1, so it's just going to be 1 again, and I end up with a half. If you have -1 and you add a half to it, you're going to end up with a -half. I probably just could have saved myself some time and replaced this too. F of 0, according to our instructions up here, is a half, so I'm going to put a half here. Now if you add a half on both sides, right? A half plus a half is 1. So once again, we end up with a c value of 1. So I'm going to come back up here to my f prime of x problem, and I'm going to get that. So there's my f prime, but that's not the final answer, remember. We want to integrate it again so that we end up with not f prime, but actual f itself. All right, so let's continue. I'm going to erase the stuff underneath of it. And now what I'm going to do is I'm going to, once again, I'm going to integrate both sides. bam, 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 bam. Just integrate every little piece, right? The integral of f prime is just f, and that's where we want to get to, right? The integral of cosine is sine, but since there's a negative in the front, we're going to keep that negative there, so it's sine. Now check this out. I'm going to take this half out and move it to the front, right? Now let's use that shortcut I shared with you. If I wanted to integrate e to the 2x, it's just going to end up being that again, right? But I have a half in front already, so now I'm going to have two halves. I've got a half from the first time I did it, and now that I've integrated again, I get another half. And then, of course, the integral of 1 is x. Don't forget your c. If I'm going too fast, you just let me know. So, simplifying it, I have this. Multiplying those two half together. And the last thing we need to do is just plug in our initial condition once again. So I'm going to plug in 0. Oops. Okay. So the 0 doesn't matter. Anything to the 0 power equals 1, so 1 times a fourth is just going to be a fourth, so we can ignore that. And sine of 0 is also 0, so that's gone. So all I have left is a fourth plus c, and then we can plug in what that is. So f of 0 is a fourth. So I have 1/4 for f of 0 is equal to 1/4 plus c. And if I subtract the 1/4 on both sides, I get a c value of 0, which means that you can put 0 in for c if you want to, but we can also just take it off, because if you add 0, it doesn't really do anything, right? And so here is our final answer for number 7.